So we will talk about today cavities of the eyeball. So basically there are two cavities. What are the two cavities? The posterior cavity and the anterior cavity. Cavity means empty space. So we have empty space before the eyeball is inserted into our cavity, eye cavity, orbit cavity. Okay. If you do see the cavity, we have anterior cavity, we have posterior cavity. Okay. So the larger posterior cavity is found between the lens and retina and contains vitreous humor or vitreous body. This semi-solid substance keeps the retina in place. If the eyeball is punctured and vitreous humor is lost, the retina may fall away from the choroid. This is one possible cause of detached retina. Okay, so basically we have anterior and posterior cavity. Okay, in the posterior cavity, backside of the eyeball. So what we have? We have the vitreous humor. So basically, we will see in this image. So basically, this is the vitreous humerus in the posterior cavity. So this is the vitreous humerus. So basically, this is the eyeball. In the eyeball, we have vitreous cavity, vitreous humor, a semi-solid substance which keep all the what we can't tell with all the layers, all the uh, structures of the eyeball in their place. So what we call if it punctured, if it is damaged by any uh, circumstances, so what will happen? The vitreous cavity will come out of this, and what will happen? Okay, the cornea, the retina, the choroid, the sclera, everything will disappear. Means will come into other place. Okay. Next, in the anterior cavity, what we have in the anterior? The anterior cavity is found between the back of the cornea and the front of the lens and contains aqueous humor, the tissue fluid of the eyeball. Aqueous humor is formed by capillaries in the ciliary body, flows anterior through the pupil and reabsorbed by the canal of Schellham. Small veins also called the scleral venous sinus. At this junction of the iris and cornea, because aqueous humor tissue fluid, you would expect it to have a nourishing function. And it does. Recall that the lens and cornea have no capillaries. They are nourished by the continuous flow of the aqueous humor. So basically, so this is the eyeball. In that we have anterior cavity. So this is the anterior cavity. In that we have aqueous humor. Okay, so basically vitreous humor and aqueous humor, this is a continuous flow of liquid, semi-solid liquid. So basically with the help of these liquids only, the lens, okay, the other parts of the eyeball, so basically they will get the nourishment. Okay, because directly they didn't have capillaries, okay, on the eyeball, on the lens, okay, on the pupil. Okay, so basically with the help of this fluid only they will get the nourishment. Okay, so I hope you understood the eyeball cavity, anterior cavity and posterior cavity. Okay, so if any doubt you can ask about this cavities. Next we have the physiology of vision. How we see, this is the question mark. We talked about the things which are situated in the eyeball, the structures of the eyeball and the layers of the eyeball and the posterior and anterior cavity of the eyeball. Okay, now we will talk about physiology of vision. So what is physiology of vision means? How the vision is coming from the outer environment to our inner environment. Okay. So let's talk about that. For us to see, light rays must be focused on the retina and the resulting nerve impulse must be transmitted to the visual areas of the cerebral cortex in the brain. In the simple, what we'll have, we have the in the outer environment, we have the all the necessary things what we can want to see. Basically, the light rays will inserted into our eyes with the help of the lens. Okay, it will enter into retina. In the retina, we have rods and cones. Rods will detect the light. Okay, cones will detect the color. Basically, after that, they are connected to the receptors, then to the neurons. Then it will the impulse will carry away from the uh, eyeball to the visual cortex area, which is situated in cerebral cortex. Okay, so this is the simple pathway of vision, how we see. Okay, and again we have to talk about this detail about the vision. Okay, then we will complete our the topic called eye. Refraction of light rays is the deflection or bending of the ray of light as it passes through one object and into another object of greater or lesser density. The refraction of light within the eye takes place in the following pathway of structure: the cornea, aqueous humor, lens, and vitreous humor. The lens is the only adjustable part of the refraction system. When looking at distant objects, the ciliary muscle is relaxed and the lens is elongated and thin. When looking at near objects, the ciliary muscle contracts to form a smaller circle. The elastic lens recoils and burns in the middle and has greater refractive power. So basically, here one term is explained, that is refraction. What does it mean? Means whenever a light rays enter into our eye, what we have, it have to bend. Okay, it have to bend. So basically, so with the help of lens, we have lens. Okay, we have the lens, then only uh, l- the layers or refraction light will enter into the eye. Okay, first the lens will adjust the refraction. Okay, whatever rays are coming, so it will adjust, it will form a straight pathway. Okay, first. Second thing, what will happen when the light rays enter into our lens, the ciliary muscles, if you are seeing to the uh, distance objects, okay, what will happen, the ciliary muscles is relaxed and it is elongated. Okay, because large amount of light rays want to enter into our eyes with the help of lenses. So that's the reason the ciliary body and the iris will dilate. Okay, then the iris light rays enter into our eyeball. If the object is near, we have to focus, means we have to zoom. So what will happen, the ciliary body muscles are constricted. So means the ciliary muscles, the iris is constricted. Means you are observing only one object. All the focus are on the one object. You are seeing nearby object. So the lens also recoils. Okay, and the the refraction and the whatever maybe the things will happen, it will constrict all the, because you have to focus on one thing. If you're if you're seeing distance objects, your uh, eye density, means your seeing to the object will differ from the nearby object. Okay, so this the refraction will happen like this. Okay, when light rays strike the retina, so what will happen, we the light rays enter into the lens. If it is distance object or maybe it will nearby object, then it will enter into the retina. What will happen, they stimulate the chemical reaction in the rods and cones. So basically how they talk to each other. If the light rays enter into retina, the retina in the retina we have rods and cones. They will release a chemical substance called rhodopsin. What will they release? They release rhodopsin. Breaks down to form scotopsin and retina, a derivative of vitamin A. These chemical reaction generates an electrical impulse, and rhodopsin is then resynthesized in a slower reaction. Adaptation to darkness, such as going outside at night, takes a little while because being in a well lit area has broken down most of the rhodopsin in the rods, and resynthesis of rhodopsin is slow. The opposite situation, perhaps being suddenly awake by a bright light, can seem almost painful. What happened is this: In darkness, the rods have resynthesized a full supply of rhodopsin, and the sudden bright light breaks down all the rhodopsin at the same time. The bridge of impulse generated is very intense, and the brain may interrupt any intense sensation as pain. A few minutes later, the bright light seems fine because the rods are recycling their rhodopsin slowly and is not breaking down all at once. So basically, what will happen when you are seeing an object? So it will enter into the lens, then iris, then ciliary muscles will attract, will do according to the situation. Is it a distance object? Is it a nearby object? Then what will happen? The light rays enter into the retina. In a retina, we have rods and cones. In there, you have chemical substance called rhodopsin. A rhodopsin will break down when the chemical, when the light rays enter into the, when the light rays, this is the rhodopsin. When the light rays entered, so what will happen? It start breakdown, and it will form scotopsin. Scotopsin nothing but vitamin A derivative. Okay. This chemical reaction generates an electron. So then if these chemical reaction, they are attached to the nerves, what will happen? Nerve endings. So it will generate the impulses. Then only from there, the impulse will enter into the brain. So what will happen? Two things will happen here. So one situation is darkness. When you are going and seeing the darkness, it will take some time. Okay. Suddenly you slept in the night. Suddenly when anyone came to you and wake up to you. Okay, suddenly when you open your eyes, suddenly one bright light will see, and again you take time to see the your environment, outer environment. So why this happen? Because of rhodopsin. So basically rhodopsin in the rod, it will present in the rod. Okay, it will break down into scotopsin, and again it resynthesize, means it again become rhodopsin. You think you that there is a small amount of rhodopsin here in the ice, so light rays enter, so it will break down into scotopsin. Okay, scotopsin. Okay, next. Okay, then you see the light and visual, everything. So basically what will happen in dark and light, though both situation, what will happen in the dark? Again this photopsin will resynthesize into rhodopsin. Basically it will take time, slowly it will resynthesize. So if you are seeing in the same condition, so these things will remain stable, but you are going in the darkness or lightness, what will happen? So the rhodopsin converted scotopsin again resynthesize into scotopsin. It will take time. So in the darkness, you you take time to see the outer environment in darkness. Okay, again in the light, bright visual field, what will happen? Sudden someone wake up you. Okay, again you want to see the environment, your outer environment. What will happen? Your bright things will enter into your light. So what will happen? It will break down the rhodopsin. So suddenly the light enters and it will break down the rhodopsin, and rhodopsin convert into scotopsin again resynthesize. So it will take fewer seconds or minutes. Again you want to see the outer environment, because the scotopsin is already converted into rhodopsin, and again is resynthesizing. That's the reason when the resynthesize is very slow process, it will take time to see the outer environment in mainly in bright light. So it mainly happens in early morning when someone wake up you. Okay, is it true or not? Give the answer in the chat box. Okay, next. So these are the things happening. The first thing is it will enter into the lens, it will reach to the ciliary bodies, then it will reach to the retina. Again, we have four condition. One, it is distance object or nearby object. Again, we have two things. It is in darkness or brightness. Okay, and next thing what will happen, then chemical will generate the impulse from that. uh, from that we have what will happen, we will talk now. Chemical reaction in the cones also involving retina and brought about by different wavelengths of light. It is believed that there are three types of cones: a red absorbing, blue absorbing, and green absorbing. Each type absorbs wavelength over about a third of the visible light spectrum. So red cones, for example, also absorb of the red, orange, and yellow. The chemical reaction in cones also generate electrical impulse, night blindness, and color blindness. The impulses from the rods, cones, are transmitted to the ganglionic neurons. These converge at the optic disc and become the optic nerve, which passes posteriorly through the wall of the eyeball. Ganglion neurons also seem to have photoreceptors called melanopsin that may contribute to the daily resetting of our biological clocks. The optic nerve from both eyes come together at the optic chiasm, just in the front of the pituitary gland. Here, the middle fibers of the each optic nerves cross the others. These crossing permits each visual area to receive impulse from both eyes, which is important for binocular vision. The visual area are in the optical lobes of the cerebral cortex. Although each eye transmits a slightly different picture, look straight ahead and close one eye at a time to see the difference between the two pictures. The visual area put them together or integrate them to make a single image that has depth and three dimensions. This is called binocular vision. The visual areas also write to the image because the image on the retina is upside down. The image on film is camera is also upside down. But we don't even realize that because we look at the picture right side up, the brain just automatically ensures that we see our world right side up. Also for near vision, the pupils constrict to block our peripheral lights that would otherwise blur the image, and the eye converge even further to keep the images on the corresponding parts of the retina. So, okay, basically here everything is explaining in detail. Okay, so already we talked about that. So basically the chemical reactions happen. So then the impulse generate. Again, here explaining that we have three types of cones. What are those? We have red absorbing, blue absorbing, and green absorbing. So basically, by the help of these absorbing cones, only we can identify all the types of images, all the type of colors. Okay, so basically when the light enters and on the it reflects on the rods and the cones, the rods will detect the light and the cones will detect the color. So they have different types of cones. We have red, green, and blue. Okay, by this mixture only they can identify the different colors also. So basically, we see the image. You can see the image. So basically, these are, you can see here. So basically, it will enter here by this help of the light rays, lenses, optic, retina. Here the retina we have. Okay, in the retina. After that, it will attach to the, we have, you can see here this image, bipolar neurons. Okay, rods and cones, bipolar neurons to ganglion neurons are attached to the optic nerve. So optic nerves will follow this pathway, optic fibers to the optic nerve to the visual field. Okay, this is the pathway of vision. Okay, next we have, next second thing we have to understood that the pupils will constrict and it will dilate. So this is also one function of the eye because of seeing distance object and for seeing nearby objects, and is also depend upon the light. So if you have further good light, so what will happen, I will just constrict because, so if a large amount of light rays enter into your eyeballs, what will happen? You already studied the rhodopsin will convert into stotopsin, and again it will resynthesize. It will take time. So I will want to save the rhodopsin, because if with the help of small amount of light rays, if it is seeing all the objects, okay, why we need large amount of light rays? So when you are seeing, so some amount of pupil is constricted, not large amount. Okay, if you are seeing in the darkness, it is more dilated, because if you are seeing the light rays, constricted. So these are the things you have to understood. Next, what will happen? The importance of convergence can be demonstrated by looking at our finger placed on the tip of the nose. You can feel your eyes more medially is maximum convergence. If the eye doesn't coverage, the result is double vision. The brain cannot make the very different images into one and settles for two. This is temporarily, however, because the brain does not like seeing double and will eventually suppress on image. You have probably heard of the condition called lazy eyes, in which a person's eye, the visual axis of each cannot be directly by precisely the same point. True converge is not possible if in untreated the brain simply will not use the lazy eye image. The eye may stop focusing and become functionally blind because the brain is ignoring the nerve impulse from it. Such loss is called amblyopia. Amblyopia, correction of lazy eyes may involve eye exercises. A patch over the good eye to make the lazy eye straighten over out and take over. Or surgery can correct an imbalance of the extrinsic muscles. You can show yourself the benefits of converging eyes the next time you are passenger in a car, not the driver. As the car is moving, close one eye. Does the oncoming landscape see to a pattern out? Lose dimension. This is loss of depth perception and some of the three-dimensionality that our brain provides. So basically here, two things are explaining that when you are seeing the image with the two eyes, so brain will combine the two images into one image, and your brain seeing you that you are seeing in one image only, because if you close the one eye, you are seeing the one image from this eye. If you close the right eye, so you are seeing one image from the left eye. So if you open both eyes, you are seeing both image as combined. So, okay, why this happening? Because of eyes are focusing on the one object in one period of time. Okay, so the eye light rays entering into retina, and the brain have the functional property that it will merge the two images into one image, and it will show you by the visual area, with the help of visual area. Okay, this is the one thing you have to understood. If what will happen if the brain is not getting the impulses from the eyes, if the brain any nerve is damaged, optic nerve, if the visual area is damaged, any pressure on visual pathway is seen, so what will happen? From the one eye you are getting the image correctly, but the second eye cannot getting the image properly in at a time. The muscles are maybe the muscles are damaged, maybe in the eyeball there is a problem or vitreous humors, okay, or in the lens, okay, on the iris. Okay, so basically if any problem in the eye pathway, in the eyeball, in the visual field or visual area, you can have visual vision defects. It may be anything. Okay, you have double vision, your vision is decreased, you have pressure on the eyeball. Okay, you may lose complete vision. Okay, so these are the things will happen if anything happen to the eyeball, visual field, visual pathway, visual area. So you have to understand these four things. Okay, so these are the things we'll explain in this all the uh, complete topic. So basically we started with eyeball structure, eyeball layers, eyeball pathway. Okay, then we how the light rays will travel into the uh, into the eyeball, then how it will convert into the light rays and into colors, then how it will connect it to the nervous system, okay, chemical, with the help of chemical, and it will travel into the visual field. Again, we will see this because of the complete picture, visual. I think we have the images. So basically, this is the visual pathway. You have the vision. So basically, understood that the vision is divided. So, okay. So this is the one imaging is showing by our pathway. So this is the left eye, right eye. You are sitting straight. So this is the left eye. This is the right eye. So right eye, left eye. So right eye, left side will see the right side. Right eye, right side will see left side. The single image. This is a symbol. It will converting the area. Okay. Then again here we have the optic nerves. With the help of optic nerves, optic nerves will take to this image to this pathway, optic tract. Okay, thalamus from the left cerebral cortex. Okay, this is the visual cortex, right visual cortex. So this image will come here and will see with the help of right visual cortex. This image will come here and it will cross the pathway at optic chiasm. We have a pituitary gland in front of optic chiasm. Okay, so these are the things are involved in visual pathway. So I hope you understood about these things. Next topic is we have glaucoma and errors of refraction also, night blindness and color blindness also. Next we have the topic of eye ear. So we will talk this tomorrow.